parallel to the principal axis is incident on the mirror, and this goes to the center of, this is a normal to the mirror. The ray after incident here reflects at the same angle. This angle is equal to this angle. Therefore, it is going to be reflecting like this is a reflected ray. And another ray which is leaving the point B on the mirror, incident on the mirror in the direction of center of curvature, is incident normally on the mirror. It is incident normally on the mirror, normal instance case. Ray turns back, reflects. Ray reflects. These two reflected rays correspond to diverging rays. Therefore, they never meet. When extrapolation, this cuts the principal axis at this point. So, where these two extrapolated lines meet, that is the image. So, therefore, this distance is the object distance, this distance is image distance, this is focal length, and we have let the point A be here and normal at this point be N. AN is normal. Now consider the triangle OBC triangle and triangle GIC triangle. Consider these two triangles. These two triangles are similar triangles. Therefore, IG by OB is equal to CI by CO. Call it as equation number 1. Okay. Next, we consider the triangle ANF and triangle GIF. Consider these two triangles, GIF, ANF. These are also similar triangles. From this, IG by AN is equal to IF by NF. This is another equation we got. But in this diagram, we observe AN and OB are equal, as OB is equal to AN. These two equations, OB is equal to AN, they are because they are opposite sides of the rectangle. We equate these two. From this, it implies CI by CO is equal to IF by NF. CI by CO is IF by NF. This is the equation we get, call it as equation number 3. But in the case of mirrors, all the distances, reference point is pole of the mirror. With relative to pole of the mirror, we measure. So CI is this distance. CI we can write it as CI is equal to PC minus PI. Similarly, CO is this distance. This distance is PO plus PC. PC plus PO. And IF is this distance, IF. What we can write IF as PF minus PI we can write. NF we consider A close to P, for A close to P. Under what conditions A will be close to P? When the object is a small linear object, when the object is small, the point A which is on the mirror instant will be close to pole. When A is close to pole, AN can be approximated as AP. That is valid for small linear objects. So AN is approximately AP. Therefore, NF is approximately PF. So therefore substituting here PC minus PI by PC plus PO is equal to PF minus PI divided by PF approximate. This is valid only in the case of point A close to P, that is small linear objects. Substituting the value, PC is radius of curvature, which is double the focal length, minus PI. PI is image distance, therefore it is V, divided by PC is 2F plus U is equal to PF is F minus V divided by F, and cross multiply these terms, that is 2F minus V into F, 2F square minus VF, that's what we got here, and cross multiplying here what we get is right side 2F square plus UF minus 2FV minus VU, we got 2F square gets cancelled, dividing throughout by UVF, you will get 1 by U plus 1 by minus V is equal to 1 by minus F. So UVF relation for an extended object, which is for case of convex mirror, is given by this formula. Here as usual U is positive real object, V is negative real virtual image, and F is negative because it is convex mirror. Now in this case IG by OB, IG is image height and OB is object height. So therefore this is what we call it as magnification. Magnification is this, substituting the values of F and U will get the magnification in this case. That magnification what we call it as transverse magnification. So next one is velocity of the image in the case of spherical mirrors when the mirror and object are moving object, moving images. So let us consider velocity of the image due to the motion of object and the mirror. This in the case of plane mirror we have come across, this already we have discussed in the case of plane mirror. Now we are considering about in the case of spherical mirror. So let us consider a concave mirror, call it as M, and an object is here at this, let us assume that this has x-axis. At a given instant, mirror pole is located at the origin, and object is on x-axis. This is what we call it as XOM, object distance from the mirror. In case if the object is here, this distance is YOM, Y coordinate of the object with relative to mirror, X coordinate of the object with relative to mirror. Correspondingly, equation for the image distance, image may be formed somewhere here based on that, image may be formed somewhere here. In that case, this is called XIM, image X coordinate, and this is YIM. YIM is the Y coordinate of the image. Now, how these two are related? This is object distance on the principal axis because x-axis happens to be principal axis here. Object distance on the principal axis is XOM. Earlier we used to call it as U, and XIM is image distance from the mirror, pole of the mirror. Therefore, this is what we used to call just now as V. Therefore, how UV related? 1 by XOM plus 1 by XIM is equal to 1 by F. The reason is real object, real image and concave mirror all are positive. Real image is positive, real image distance is positive as per the sign convention. Real object distance also is positive as per the sign convention, and focal length of the mirror also is positive as per the sign convention. Now we differentiate this dxom by dt in case if there is a change in the position of the object relative